Hello everyone, today we're going to be going over the August 2024 Algebra 1 Regents exam. In this video, we're going to be looking at part 3, which is 4 short response questions worth 4 points each. A link to this test is going to be found in the description of the video, and a link to a video going over the next part of the test is also going to be there if you want to keep on going over. That being said, we're going to start off with 31, which tells us that the owner of an ice cream stand kept track of the number of ice cream cones that were sold each day of the first week in June. She compared the ice cream sales to the average daily temperature, and the data are shown in the table below. The problem is asking us to state a linear regression equation for the data, rounding each number to the nearest hundred. That's pretty important. So all we have to do here is use our calculator to solve the problem. Whenever it's asking us to use a linear regression, we're going to go ahead, enter a calculator, press stats, and then enter. And it's going to bring us to this menu that tells us to make lists. So in this case, we're going to have to copy this entire table into two lists on our calculator. Just whenever you're doing this, make sure to keep the numbers together. So this row represents all of the x's. You should, whenever you're entering your data into the calculator, make sure to keep all of the x's together. All of this should be one list, and all of this, all of the y's, should be their own list as well. Okay, so keep them separate because that's important. Once you have entered those into your calculator, you're going to press second mode to quit that. Then you're going to press stats again and scroll one to the right to the calc menu. And then you're just going to scroll down to linear regression, linreg, it stands for linear regression, and press enter. So you can see here why it was important, why we separated our lists, because list 1 is going to be the x and list 2 is going to be the y, right? If you mix them, your data would be messed up. So you're just going to go ahead and click enter or calculate, and it's going to give you the linear regression. It's going to give you y equals ax plus b, and then it's going to tell you what your a is. In this case, that's 15.125, and it's going to tell you what your b is, which is negative 959.625. So negative 959.625. So in this case, your job is to just plug these values into y equals ax plus b. So your linear regression equation is going to be y equals a, which is 15.13. Remember, you round to the nearest hundredth, times x, plus b, which is actually just going to be minus 959.63. That is your linear regression. Now, the second part of this problem asks us to state the correlation coefficient. Now, in order to access your correlation coefficient, you're going to have to quit, and you're going to have to turn on a special setting on your calculator if you haven't done this before. You're going to have to go second 0 to get into the catalog, and you're going to go ahead and scroll down to where it says diagnostics over here. So diagnostic on. Hit diagnostic on and enter, and then go back into stats, calc, linear regression, enter. And over here, you're going to see that two new values popped up. So you have an r squared and an r. Your r is going to be your correlation coefficient. Okay, so all you have to do is just look in your calculator, see where your r is, and put it here. So your correlation coefficient is 0.99. That's it. Round it to the nearest hundredth, and you get full points for that part. So now all you need to do is state where the correlation coefficient indicates about the linear fit of the data. So what does this 0.99 mean? So you need to remember that the correlation coefficient is a value that can range from -1 to 1. Okay? So it ranges from -1 to 1. The closer it is to -1 and 1, the stronger the fit is. So if the correlation coefficient is 1, that means that there is a positive linear fit to the data. And if it's -1, that means that there is a there's a negative linear fit. Now, oftentimes your r is never going to be 1 or -1. It's going to be some decimal that's either close to one of the two values. So if it's close, then you say it's a strong positive linear fit or a strong negative linear fit. It pretty much says that most of your data is going to be either sloping downwards or sloping upwards. Okay, so in this case, 0.99 is very close to 1. So we can conclude that the correlation coefficient indicates that there is a strong positive linear fit to our data. Okay. So the correlation coefficient indicates that there is a strong positive linear fit. That's all you have to say. There's a strong positive linear fit. There's a strong positive linear fit to the data. The data is positive and linear. Either way, you just need to remember that as long as the correlation coefficient is close to -1 or close to +1 or -1, it's going to be a strong positive or negative fit. If it's close to 0, then it's a weak fit, and if it's 0, then there's no fit. Okay? That's how you score full points on the first question. Moving on to the second question, it asks us to graph the system of inequalities on the set of axes below. Okay, so in order for us to graph something, it needs to be in the form y equals mx plus b. So this first equation is in the form y equals mx plus b, but this second equation isn't. So before I want to even graph the first one, I want to make sure that both of these are in the same form. So I need to rewrite x plus 2y is less than or equal to 6 in this y equals mx plus b form. So I'm going to have to subtract x on both sides, and I get that 2y is less than or equal to 6 minus x. And I can rewrite 6 minus x as negative x plus 6. Okay? So I have 2y is less than or equal to negative x plus 6. I'm going to divide both sides by 2, and I get that y is less than or equal to negative 1/2 x plus 3. Okay? So now I have this rewritten in a form that I can understand and graph it with. Okay, so now that I have it in y equals mx plus b form, it's going to be super easy to graph. So I'm going to do these in 2 different colors. So the first one I'm going to do in red, and I'm going to say that this one is in red. So the first point that you want to plot on any graph is always going to be your y-intercept. The y-intercept is the point where x is 0, and it's the point where the graph touches the y-axis for the first time. So in that case, that's your b. So that's the number that doesn't have the x next to it. Okay, so this -4 means that your y-intercept is -4. So we're going to go down here, 1, 2, 3, 4, and we're going to put our first point there. Now, in order to graph something, one really easy way to do it is to remember that m, which is your slope, is equal to rise over run. Okay, so in this case, your slope or your m is always going to be the number in front of the x. So the number in front of the x for this is 3, okay? Or 3 over 1, okay? So that means that your rise is 3 and your run is 1. So the slope is going to make you go up 3. So you're going to go up 1, 2, 3, and it's going to make you run to the right 1. So you're going to go up 1, 2, 3, and to the right 1. 1, 2, 3, 1. 1, 2, 1, 2, 3, 1. Okay, and you're going to do that opposite to go down. So 1, 2, 3, 1, 2, 3, 1. Okay, or you don't even need that extra point. So now that you have your sum points down, you're going to take your straight edge, which you're going to be provided on the day of the test. I erased some points by accident, and you're just going to draw a straight line through those points, right? I don't have a ruler on me, so my line is going to be pretty crooked, but just pretend like this is a straight line and you'll get full points, right? Now, that would actually be the mistake here that the Regents is hoping a lot of students go for, because this, you have your points, but this graph is a greater than graph, right? It's not a greater than or equal to graph, it's a greater than graph. Whenever you have a greater than or a less than sign, your line is going to be dotted. So you need to draw dashed lines through these points, okay? So this is one of the tricks about graphing inequalities. That line is not always going to be solid, okay? So you draw a dotted line, you put your 2 arrows there, and you label your graph, right? You always need a label that this is y is greater than 3x minus 4, okay? And now, because y is greater, you need to shade up. So the way that I know how to shade up to show my solution zone here is I just take any point and I draw an arrow up of it. And that's how I know that I'm shading up. So whenever y is bigger, whenever the arrow is pointing y, you know that you're going to have to shade upwards, okay? So just know that the lines are going to have to go here. This is how you show the solutions to the line. Okay, So now that we have that done, we need to go ahead and graph our second point. So our second point I'm going to do in green. And now we have that y is less than or equal to negative 1/2 x plus 3. So again, following our rule, the first point that I want to graph is the y-intercept. So I'm going to go 1, 2, 3, and I'm going to put my first point down. Now, remember our rule with slope, right? It's rise over run. So here, negative 1 over 2. So my rise is negative 1, which means I go down by 1 and to the right by 2. So from this point, I'm going to go down by 1 and to the right by 2. So down 1 and to the right by 2. Right here, down 1, right by 2, down 1, right by 2, down 1, right by 2. Okay, and I'm going to do that in the opposite direction to get the points above. So now, in this case, I have my points and I'm ready to draw my line through them. In this case, I have y is less than or equal to. So because I have a less than or equal to or greater than or equal to sign, my line is going to be filled in, okay? You just have to remember the difference between the two. Okay, so I'm going to draw a straight line between all of these points. Again, I don't have a ruler, so it's kind of difficult. Make sure I have an arrow on both sides and make sure to label the graph, right? So I'm going to label this as x plus 2y is greater than or equal, is less than or equal to 6. Okay, if you don't label your graphs, you don't label which one is which, you will get points taken off. And now, because y is less than, because the arrow is pointing towards the x and not towards the y, we're going to have to shade down. So if you're confused on which position is down and which position is up, just take a random point and go down, and that shows you where you're going to shade. So you're shading down, so it's going to look something like this. It's going to be messy when you do it, but going to shade down and all the way down. Don't just stop at this line. Keep on going through that line, okay? So it might be easier if we label this above the line, actually. So I'm going to go ahead and do that. So here I have y is less than or equal to negative 1/2 x plus 3, or you can label it as it was originally, which would be x plus 2y is greater than or equal to 6, or less than or equal to 6. Finally, the last thing you need to do is you need to see where the two lines intersect and just write S. And this represents the solution, okay? So as long as that's clear, as long as your lines have been graphed properly, are labeled properly, you have them shaded properly, and a clear solution, you will get full points on this, okay? So finally, the last part of this, and don't forget to skip this. Don't forget that this part exists, right? A lot of students just graph it and they move on to the next part of the question. There is a second part to this. It asks us, is the point 2, 2 a solution for the system? Okay, so the point 2, 2 lies here. And you can kind of see that it actually lies on both the red and the green parts of the graph. And it's asking us, is it a solution to the system? Which means that it's asking whether or not this satisfies both, right? Both of these equations. Now, the points that do satisfy both of the equations lie within our S. Okay, so any points within this region is going to satisfy both of these inequalities. But this one is on the border of it, right? It's not deeply in this solution zone. It's on the edge of it. And the point 2, 2 lies on both of the lines. Now, one of the lines is dashed, which means that that any point on this dashed line is not a solution. So because the point 2, 2 is on a dashed line, it's not a solution. Okay? So we need to conclude that no, 2, 2, and I'll write that a little bit neater for you guys. We just conclude that no, 2, 2 is not a solution to the system, because it lies outside of solution zone and on a dotted line. Now, another way you can justify this is by plugging in 2, 2 into both of these inequalities and showing how it does not satisfy the top one. But as long as you say that it lies on the dotted line, again, that would be enough for the Regents, okay? So remember, if it lies on the filled in line, perfectly okay, that's a solution. But if it lies on the dotted line, it's not a solution. And it has to be a solution to both of the lines. So sure, it lies on this solid line, which means it's a solution to this, but it's not a solution to that. And it needs to be a solution to both in order to be correct. Okay, moving on to number 33, it says that an object is launched upward at 64 feet per second from a platform 80 feet above the ground. The function s of t models the height of the object t seconds after the launch. If s of t is equal to negative 16t squared plus 64t plus 80, state the vertex s of t and explain in detail what each coordinate means in the context of the problem. So you need to remember that a vertex is a very specific and a very important part of the parabola, right? This is going to be a parabola. How do we know? Because it has x squared or t squared or some variable squared. That means that if we were to graph this out on our calculator, it would look something like this, right? Now, in general, parabolas can follow two shapes. They can be facing downwards or facing upwards, and the vertex is always going to be the peak, either the bottom of it or the top point. So it's either the top point or the bottom point of that graph. Okay, so in this case, the easiest way to find the vertex is to use your calculator. So all we're going to do is we're going to go ahead, enter our calculator, and enter this equation. So y equals negative 16x squared. It's okay if you use x instead of t. Plus 64x plus 80. Okay, and we're going to go ahead and graph it. And obviously, it's not going to show our graph because this window is too small, so we can always go into zoom, and then we can always go into zoom fit, right? So z fit, zoom fit, okay? And here it kind of alters the window so that you can kind of see the parabola, and you can see that it takes that shape, this downwards facing shape, and over here the peak is what we're going to call the vertex, right? The vertex is either all the tippy top of it or all the way at the bottom. Okay, so now that we see the vertex, the way that we calculate it is we press second, trace, and in this case it's our maximum. Okay, why is it our maximum? Because it's all the way at the top. The function goes to this point and then it continues to decrease. So it's increasing, 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 and then it starts to decrease. Now, in order to calculate this, you just select one point before the vertex and then one point after the vertex. And then when it asks you to guess, you're going to move this cursor to where you think the vertex is. So honestly, I think the vertex is somewhere around here, and then you press enter. And it tells you that the maximum, or your vertex, is at x equals 1.99999, which you round up to 2. So the vertex is at 2, comma, 144. So here we just stated that the vertex is 2, comma 144. If we leave it at that, we get this part wrong because they're asking us to explain in detail what each coordinate means in the context of the problem. So s of t models the height of the object t seconds after the launch. So s of t, which is your y, is going to model what? Well, it's going to model the height, and t seconds after the launch, that means that your x, or your t, is going to be time after launch. Okay, so this means that, notice how we calculated the maximum. This means that the object reached its maximum height of how many feet? Well, 144 feet, 2 seconds after it was launched. And that's all you need to say here, right? This 2 means that after 2 seconds, it reached 144 feet in the air. But what makes this point special is that it's the maximum. And because it's the maximum, this is the highest that it will ever go. Okay, so as long as you reflect that, you will be okay. Then it says that after the object is launched, how many seconds does it take for the object to hit the ground? Okay, so if we think about it this way, this graph looks something like this. where this is going to be, the y is going to be your height above the ground. Okay? Now, if you're on the ground, how tall are you, right? If you're literally lying down on the floor is always going to be 0, right? The floor is always going to be 0 feet. And it's kind of awkward to explain that because it's intuitive. Like, it's duh, right? The ground level is going to be at 0 feet, right? So anywhere along here, the x-axis is kind of the floor. If we imagine this to be the path of the object, then it's on the floor here, and then it's also back on the floor here, right? Now, if we look at our graph here, the object goes above the ground, right? Because the y-axis, it's non-zero, it's above 0. Then it flies for some distance, and then it hits the ground or the x-axis, and then it keeps falling, right? So if we say that the ground is the x-axis, how many seconds does it take for the object to hit the ground again is going to be the x-intercept, or this point, this weird random point where the graph is 0 again, okay? So remember that whenever the height is 0 or the y is 0, that's generally going to be the ground in the problem, okay? So the way that we calculate that is, again, we go into second, trace, and we hit 0. And in this case, when it asks us for a left bound, we're going to choose a point to the left of the 0 that we're trying to solve for, which is here. And we're going to choose a point that's to the right of the 0. And when it asks us to guess, we're going to put the cursor over where we think the 0 is, which I guess it's here. And then it says that the 0 is at x equals 5. Okay? So that means that when t is equal to 5 seconds, the height, which is h of t, is equal to 0. Thus, the object takes 5 seconds to hit the ground. And then to justify this, we can say that h of 5 is equal to 0, or the x-intercept is the point, or is at the point 5, 0, right? So h of 5 is equal to 0 would be enough to justify this. The x-intercept is 5, 0 would be enough to justify it. 5 is a 0 of the function. Again, it would be enough to justify it, okay? But what they're trying to test you for is to see whether you understand this. And I guarantee you a problem like this will be on some Regents test that you're going to take. My best advice is to treat the graph like the trajectory, right? Treat the graph as if it's the object's path, right? So, and then also treat this x-axis like it's the ground. So the object goes up, goes up, goes up, goes up, and it hits the ground at this point, okay? So now, number 34 asks us to solve the system of equations algebraically for all values of x and y. So in this case, we're going to look for the solutions that makes both of these equations equal to one another, okay? So both of these equations are already in terms of y. So if I want to look for the x and the y values that make both of them true or both of them equal to one another, I'm just going to have to set them equal to each other, okay? And I can do that because they're both in terms of y. So this guy is equal to y, and this guy is equal to y. So I can just set them equal to each other because they're equal to the same thing. So I can say that x squared plus 4x minus 1 is equal to 2x plus 7, and just solve for x here. So now, all I have to do is combine like terms, so I can subtract 2x from both sides, and I get that x squared plus 2x minus 1 is equal to 7, and I could subtract 7 on both sides, and I get that x squared plus 2x minus 8 is equal to 0. So now I can factor out this quadratic, and I'm going to use FOIL. So I'm going to look for a number that multiplies into -8 but adds into 2. And that number is going to be 4 and -2, right? 4 times -2 is -8, and 4 plus -2 is 2. So now that I know the two numbers that I are going to multiply into -8 and add into 4, I can split this this quadratic in half. So I can split it into x squared minus 2x plus 4x minus 8. So this is the exact same thing as saying x squared plus 2x minus 8. All I did was I just split this 2x in half, okay? And when I split this 2x in half, I can factor from this side an x out. So I divide both of these by x and I get x minus 2. And I can factor out a 4 from both sides here. And if I divide both of these terms by 4, I get x minus 2. So now I split this up into two equal parts. I combine these x minus 2's into one parenthesis, or one set of parentheses, and I combine this x and this 4 into an x plus 4 in their own set of parentheses. And now I have that x plus 4 times x minus 2 is equal to 0. Now, remember that anything times 0 is equal to 0. So as long as one of these parentheses is equal to 0, the whole function is true, meaning it's equal to 0. So that means that x plus 4 has to equal to 0, and x minus 2 has to equal to 0. If we subtract 4 on both sides, we get that x is equal to negative 4. If we add 2 on both sides, we get that x is equal to 2. So there's two solutions to it. The first solution is when x is equal to negative 4, and the second solution is when x is equal to 2. Now, is this your answer? No, it's not your answer, because in order to solve the system of equations, you need to solve it for all values of x and y. Now, I already know that x is equal to negative 4 and that x is equal to 2. So what can I do? Well, I can plug these two values into one of these equations, right? We already know that y is equal to 2x plus 7. So let's just plug in negative 4 for x. So we have y is equal to 2 times negative 4 plus 7. So y is equal to negative 8 plus 7. So y is equal to negative 1. And finally, if we plug in 2 for x, we get y is equal to 4 plus 7. 2 times 2 is 4. 4 plus 7 is 11. So now we just match up these points with whatever x value we put in. So now we're left with the point negative 4 comma negative 1 and 2 comma 11. Okay? So this is all we need to get full credit here, right? We need two coordinates that we get from first solving x by setting the two equations equal to one another, and then plugging these two values back into one of these equations. I chose the bottom one because the top one would involve me squaring stuff, and that would have taken too long. And this is the end of part 3. If you want me to go over part 4, that video will be found in the description of this one. If you have any questions on any part of this test, please let me know. I can answer them in the comments. If you'd like for me to go over any specific questions or any specific test other than this one, again, let me know in the comments. Other than that, I hope you guys learned something, and I hope you have a nice day.